They're in your pocket, they're helping power our cities, and they are, without a doubt, shaping our future. We're talking about the hidden ingredients of our entire modern world. And today, we're going to pull back the curtain on the fascinating and strategically vital world of rare earth elements.
So, let me ask you a question. What on earth does the phone in your hand have in common with a giant spinning wind turbine? It sounds kind of like a riddle, right? Well, the answer is a very special family of materials that are absolutely critical for both.
All right, so here's our roadmap. First, we'll break down what these rare earths actually are. Then, we'll get into their magic properties, what makes them so special. We'll follow their intense journey from rock to a refined product and see why it's way harder than refining oil. And finally, we'll look at the global power struggle that this whole process has created.
Okay, let's dive right in. What are we even talking about when we say rare earths? Well, it all starts with that part of the periodic table you probably ignored in high school chemistry.
Officially, rare earth elements are a group of 17 metals. You know, that separate, kind of lonely-looking row at the very bottom of the periodic table? That's then, the lanthanides plus two other buddies, scandium and yttrium. They're all lumped together because they have these really unique and powerful properties.
Now, this is the first big myth we have to bust. The name rare earth is super misleading. It's not that they're hard to find in the ground. Some are actually more common than lead. The real challenge, the thing that makes them so valuable and, well, rare in a practical sense, is that they are an absolute nightmare to separate from one another.
So why do we go to all this incredible trouble? Well, because these elements are basically the secret sauce, the magic ingredient that makes so much of our high-tech world actually work.
And they are literally everywhere. The phone that vibrates in your pocket, the motor in an electric car or a wind turbine, that's thanks to unbelievably strong, lightweight magnets made with neodymium. Those super vibrant reds and greens on your screen, you can thank elements like europium and terbium. And the internet itself, zipping through fiber optic cables, yep, that relies on them too.
So what's their superpower? It all comes down to their atomic structure. They have these special electrons, called 4F electrons, that are like tiny, super-powered compass needles. But here's the genius part. Those electrons are shielded deep inside the atom. This lets them all line up and point in the same direction, and more importantly, they stay pinned in place even when things get hot. That incredible stability is what makes them a total game changer. Okay, so now let's talk about the process. Getting these magical elements out of a rock and into a motor is one of the toughest industrial jobs on the planet. It is a long, messy, and brutal journey.
Think of it like an industrial gauntlet. First, you crush tons and tons of ore into a powder. Then you have to crack it open with some seriously strong acids. After that, you leach it, basically dissolving the rare earths into a liquid chemical soup. But all of that is just the warm-up for the final step, the monster at the end of the level, separation.
And this quote just nails the problem, because all these rare earth elements are so chemically similar, they cling together. You can't just filter them out. You have to run this chemical soup through hundreds, sometimes thousands of identical stages, each one separating them just a tiny, tiny bit more. It's incredibly complex and uses a mind-boggling amount of energy.
To really get a sense of how hard this is, let's compare it to something we all know. Crude oil. I mean, you pull a raw material from the ground and refine it, right? Sounds similar. But in reality, they are worlds apart.
Look, refining oil is basically a physical process. You just heat it up and different parts boil off at different temperatures. It's efficient and you can switch between different types of crude oil pretty easily. Rare earth refining, it's a chemical nightmare. The whole process is custom built for one specific ore chemistry. You can't just swap things out. A factory that needs pure neodymium can't just use its neighbor on the periodic table. There is zero flexibility.
And this incredible difficulty, this chemical rigidity, leads us straight into the final and most important part of this story, the geopolitics. Because if you're the one country that has mastered this ridiculously hard process, you suddenly have a lot of power. Just look at this number for a second. 91%. Let that sink in. What do you think that represents? It's not how much is mined. It's something way, way more important. That number is China's share of global rare earth refining. The hard part. The part that really matters. So while other countries might dig the rocks out of the ground, almost all of it gets shipped to China to be turned into usable material. The rest of the entire world is fighting over the 9% that's left. And this is the single most important takeaway.
Having the minerals in the ground is not the same as controlling them. True power, real control, comes from the midstream, from owning the complex, expensive industrial know-how to turn those rocks into the pure metals technology actually needs.
And this chart drives that point home perfectly. Look at the reserves. Yeah, China has a lot, but Brazil, India, Australia, even the US, they all have significant deposits. But without the massive refining infrastructure, those reserves are just, well, they're just interesting geology. They're rocks in the ground.
So that leaves us with a huge question. As we race toward a future of electric cars, wind power, and smarter tech, a future that absolutely depends on these elements, you have to ask, who really holds the power? It's not just an industrial question anymore. It's one of the biggest strategic questions of our time.